So you can see games are mathematical models, right? Teaching with Kerbal Space Program, that's my talk. So now it should advance. Let's see, how about that? Here is all of the things that I want to hit on is just games as mathematical models. This game that I discovered a few years ago, Kerbal Space Program, it is a model solar system. I did a grant with NASA to create a course that was based on that game, and then I created a workbook as part of developing that grant and developing that course. So first, interesting parallels between doing mathematics and playing games. I think in both we simulate some real life activity or other phenomena with some rules and assumptions, both in games and mathematical models. And in math, we can ask, what can we discover or achieve with a given set of axioms while we're playing by these rules of math and logic? And then in the game, it's just what can we discover or achieve while we're playing by the rules of the game? And of course, there's a Super Bowl later today. So maybe one team is trying to prove a theorem that they are the better team, right? At least in that one day. But in this game, it's a computer game, and it's available there, kerbalspaceprogram.com, and it really, for me, I think is beautiful how it illustrates this universality of math and physics, because it's a different solar system where all of the same textbook rules of physics and math apply in this alternate solar system. Fully multidisciplinary because you're designing and you're learning science and math along the way, and it's modeling Newtonian physics with patched conic trajectories, which now I know really what that means, and it's a beautiful, fascinating story. There are multiple planets and moons that some have atmosphere and some don't, so it really creates this virtual lab environment for experimenting in, and players are building rockets and satellites and landers and rovers, and it goes on and on. That's a picture there in the corner of somebody that built a train. You could do that too. There is a huge community of players, and there are extensions and mods that add to the game. And I got this grant in, I guess it was, well, it was in, when was it? I don't know, COVID.
Spring 2019, I think.
No, well, that's when I started playing around with Kerbal, but I think the grant was really in the the class that I did was fall 2020, so it was summer of 2020 when I actually got approved on it. This was the thing also; it was always kind of like last minute things, crossing T's and dotting I's. But it worked, and it was beautiful. It was a fantastic, positive experience. It was the grant that made it possible to do the course, and it was all about promoting math and physics literacy and promoting STEM majors. And the goal was to complete some of the material in the workbook that I wrote. And also a goal there was studying the enrollment and the demographic data in STEM at Montgomery County Community College. That's where I'm teaching. It's a suburb of Philadelphia. So combine the 2 semesters, I had 30 students, and I got 23 successfully to complete those goals, and all of the goals were completed, and it was really, really beautiful, satisfying thing. And looking back, one of the things that was really neat is that there were a number of majors, non-STEM majors that were interested, and really can confirm, like, not just, several students that really were motivated to change into STEM majors as a result of this. And do other programs as a result of this. So that's a video link there to a video I made about that course. It was offered in fall 2020 and then again in spring 2021 because we had some money left over after the fall to last minute, hey, can we do it again? Yes, you can do it again. And then we did it again. And then it was cost sharing with Vaughen, where I teach, and this NASA Pennsylvania Space Grant Consortium that approved it. We completed exercises from the workbook that I wrote. It was a 1-credit class. We were actually meeting 2 hours a week on Zoom. And one of the really amazing things also was the guest speakers that I got to join in. And I wrote this workbook. Part of what I'm trying to achieve here is to share with you the material that's in that workbook and the things that we did in the idea that maybe something here will catch your interest so you could develop it in your own way. It's based on examples from the game, but also real life examples. it would be useful for just really traditional classes. You could use it there, and as lab activities, project-based learning. I'm going to say something like challenging questions that you can't just look up on Chegg necessarily, because it's, outside of the tradition. And it would be beautiful for clubs and perhaps summer enrichment programs, is what I have in mind here. So this is just from the spring class, what we actually ended up doing. I had that big block in there where I had a bunch of speakers that I didn't know when they were going to be available and how it was going to work. So they all lined up right there, and it was just so fantastic. The speaker element of this was amazing. But we started with talking about just basic things about gravity and acceleration. This was an introductory algebra level kind of course. So, but there were opportunities all along the way to talk about, where we would go in terms of calculus and trigonometry. I did stuff with navigation, and there were some places where I could talk about rates of change and get into calculus, and of course the rocket equation was a thing that was beautiful. I'll just say then the speakers that I had. One of them was just an amazing luck. Scott Manley is big deal in rocket science and astronomy, and he came to the class each semester to talk to the students, and that was an amazing thing for me also to learn from him. And I've got more material that I need to add to the workbook from the conversations with him. The company that publishes the game also allowed some of their programmers and developers to come talk to the class. And so then I was realizing this is really attractive for students that are just interested in computer science and game programming. And this kind of brought them into talking about math and physics also. And that was a really fantastic thing. They came both semesters to talk about that. Cody Short was a speaker who is modeling orbital dynamics, and he talked about his career, and that was amazing. And he suggested that he could do that again, so we may do that again. This was a former student at Montco who had gone on to Temple and done an engineering degree, and then was working as an engineer. And he came back and talked about control systems and differential equations and how everything is a spring, is what I learned from him. And that was just really neat. So now I'm going to just talk about this game and how it worked in a math class. And the first thing that occurs to me is how it's almost like a 3D graphing calculator. You do what I thought we were going to do is basically do some math, sort of some kind of model, predict something, and then we could check to see if it actually happened in the game, because the game is following exactly textbook math and physics. So we were illustrating really general principles that work in any solar system. And then you could also experiment with changing parameters. And that was like a graphing calculator to me. It was also to me like a STEM lab, because we could collect data from the game. And this is a plot where I thought even in a beginning algebra, I could talk about relative max and min. What does this even mean? Talking about increasing and decreasing. This is the speed of a rocket. It's launching at higher and higher, gaining speed until its engines burn out. It slows until it reaches its maximum height, which would be when it gets to a lowest speed down here just before 200 seconds. And then it begins to fall and gain speed. Then it hits the atmosphere and slows down again. And then the parachutes deploy. Perhaps it's right after 300 seconds. And then more parachutes deploy, and then it lands. And just that was a neat thing. When I looked at that graph, I was like, what the heck is that? And it took me a few minutes to figure out, oh yeah. These are some comments from the students after the course, like, why did you even take it? Try something new, out of my comfort level. I think that was not originally a STEM major. And one student said that they had learned the universality of math and physics. So I was like, perfect, that's exactly what I wanted to achieve. And the ingenuity of rocket science, I'm completely there with that student. And also, I agree as well. Like, I learned in developing the material about the vis-viva equation and the rocket equation. And these are just simple little things that if you've never heard of them, add them into your math class. I think algebra, pre-calc, calculus, they're amazing. A student, this is not only one, but more than one, really did change from non-STEM into STEM as a result. And it was just a small group, right? So it was positive. Highlight of the semester, recommend, because it really connected with the fun and the learning. So traditional math classes, maybe you might feel personally judged when you get something wrong. But in a game, you just, it's part of the game. You fail and you try again, you respawn. That's just expected and completely, acceptable. And also, I think just the whole idea of play is really useful at developing intuitions and thinking about really an integrated picture. Rather than just doing one problem and solving it, you really have multiple elements of what's going on that you've got to really put together. And then maybe you see something in a different way. A novel solution is possible there when you're playing. So I will now just go through some of the things that were just fun to discover, just how the universality of this formula for orbital speed can just be, just plug in a different mass for a different planet and different radius for orbit, and experiment with that and see it play out actually, dynamically in the game is fun. One of the things that also was just, like early on when I really had no connection to this, it was just really fascinating for me to discover about, how when you're on the International Space Station, your weight is effectively like 88% of your surface weight. But why are these astronauts floating around in the International Space Station? And that's a great discussion about, this horizontal speed that's without any or minimal drag. They're just basically falling and falling and falling. And that's why they look weightless. And that was a neat algebra and science lesson. And then there are really labs that I've created in there, which this is like something that you don't really need Kerbal for this, but in Kerbal, you can just, track the time and the altitude and the speed, and then just estimate the acceleration. And you could actually do that with a video on YouTube. You could just pause somebody, a launch of SpaceX. You could just pause, write down the time and the speed. And I realized, well, yeah, that works. I've done that in another lesson as well in here, but this was from a launch in Kerbal. And so, yeah, we looked at the velocity over time, and here I'm in an algebra discussion. It just talked about the average acceleration. From that, I can get average g-force. And yeah, with KSP or real life data. This is a student's work in calculating the direction to get from the Apollo 11 landing site to the Apollo 12 landing site. And I just thought, oh yeah, latitude, longitude on the moon is a good, fascinating discussion. And then the trig of the shortest path is interesting. And then you can really explore on the moon, which is called the MUN in KSP. And I have this video about some calculus-based derivation of navigation formulas. In that course, we just did use the formula, do the calculation, and then we could check it in the game. That was part of the grant, paid for the game for the students that were in that class, in the KSP class. But what I'm also talking about as I go through these, in some cases, are places where I could just use this material in my regular class. This is some algebra for finding the added speed that you would need to move in a transfer orbit from orbit around Earth to the moon, reach out to the moon, or a moon in Kerbal. And then there's some videos here where I'm both checking that in Kerbal, like what's the required added speed to reach the moon, and then actually by the transcript of the Apollo 11 mission. So that's a really neat discovery to find that Apollo in real-time website. This is another place where I think about the universality of math and physics, that I can look at the orbital data, like semi-major axis and period of planets in the Kerbal system, and teach properties of the log functions, teach Kepler's third law, and this applies to a different solar system. And it's kind of fun to see that, just that discovery that it's this fundamental principle between these, semi-major axis and period, and that's a great lesson that's I just love. this is measuring velocity and pitch during orbit and seeing how you can calculate the specific orbital energy and also the angular momentum and confirm that they're the same at different points in flight, and what the eccentricity would be and how that matches to the appropriate conic. And that's all kind of like a collect data in the game and then understand the math. A beautiful relationship between the direction when you launch. I'm thinking about, when you say which direction does the rocket go, it's supposed to go up, but it also has to fly in a particular direction relative to north, and that actually affects the inclination of the orbit, and it depends on the latitude you're launching from. This is beautiful three-dimensional geometry that's also related to navigation. That's not even that complicated of an equation to model that in, very accurately, and just make some discoveries, like, for example, at Kennedy Space Center, you cannot launch directly into an equatorial orbit from Kennedy Space Center. This is a student working out what direction do you have to launch relative to north. I mean, of course, you have to go up, but you have to go 45 degrees to north to reach the International Space Station. So what about the difference between just checking an answer in the back of the book, or even if you Google search to see if you got it right, versus actually experiencing it in a simulation that's dynamic and interactive? I think those are really, really fun and a good way to experience the learning, right? In calculus, of course, you got to do max Q. You hear that every launch, and so we look at velocity data, or actually, I'm sorry, I can collect the atmospheric pressure on the rocket during the launch from the game, and I can fit that data to a curve and then just find the max in the Calc 1 class. And then this is a Calc 1 lesson where I'm actually looking at the velocity again, but it actually wasn't really linear. I can estimate acceleration at different points and find G at, the G-force at different points, and I can do that with an actual launch by just hitting pause during a video on YouTube, or I can use data from the game. And then how about Newton's method, solving Kepler's equation? Those are both just beautiful, fascinating history lessons. And then you're also really seeing why a numerical method is required and what is a numerical method. And then, now I know what that little diagram is up there in the top left corner. It's a model for understanding Kepler's equation, and so there's a lesson there in solving that equation with Newton's method that I have in the workbook. I have there actually an interactive for that, but I should probably keep going. Escape velocity is a lesson that can be in the Calc 2 class, finding the work done by an improper integral, and then it's also, it's a lesson in the principle of work and energy, and I did in this lesson here examples with the Mars 2020 Perseverance mission, the Apollo mission, and can do an example in KSP. So this is in the workbook, that I have that kind of material with answers that are static answers in the back of the workbook, but you can also experience it in the game. This is a fascinating lesson for the end of our Calc 2. We do calculus with parametric and polar functions, and here's a polar function that describes the orbit. You can relate that to the pitch of the spacecraft, and in the game you can actually track the pitch mathematically and see that it follows as it should with the the orbit that you're in. So that's a really fun lesson to explore, and some really, really good calculus. There is a lesson here for the Calc 3 about using Lagrange multipliers to find the theoretically optimal mass of each stage in a multi-stage rocket. And that actually was inspired by the end of the section in the Stewart book. We used the Stewart book for calculus at Monco, and there's a lesson there. But this in my workbook, I go in a little bit further than what's in the Stewart book. I use some slightly different questions that are in the Stewart book. So yeah, and this is the first example that I have of an application for Lagrange multipliers that's in my course. I mean, I'm sure there's lots of other applications, but it's one that I can really talk to the students about. Whether or not it actually becomes an assignment in that class, I'm not sure yet, but I can tell them that I have a real application of it. And yeah, and I think that's, it's fascinating for me. And I think I can get that across to the students as well. Here's some differential equations. So this is actually the talk that I did last year where I studied the launch of a rocket in the first few seconds when it's um, launching, and I used Euler's method to basically calculate in Mathematica and Excel what the velocity should be when you've got gravity and you've got thrust and you've got increasing drag as it gets faster and faster. And then I checked it in KSP, and I was able to get a very good model mathematically that corresponded to what we saw in the game. And that was really fun. And then, yeah, we're able to look at the time and the altitude and the speed, and then we're able to predict what the altitude should be and confirm that in the game. And that's all this material that I have in the workbook. And then this is something I'm working on right now with Hector, where we'll look at an airplane and the differential equations that result from a model when you've got a thrust and you've got drag and you've got weight. And sometimes a glider can start to oscillate up and down. As it goes down, it picks up speed, which gives it lift, which brings it back up, and then the drag will slow it down and it'll get into this oscillation. It might even loop if it has enough initial speed. And so, yeah, Hector and I have been working on putting together how we could use that model to predict the behavior, like in Kerbal, but also in other flight simulators. That's actually the end. So I think I made it. I have some links there in this slide for an intro on my project, and then the video about what I did in the fall, another one about what I did both fall and spring. This is a video that actually was the last one on that list, is something that the publisher of the game produced 10 years after the game was released. Just last year, they produced this video that really talks about its educational value from lots of people, including I have like 5 seconds in that video where I say, yeah, I really like this game and it's been great educationally, something to that effect. And so this is another link to that workbook that I have been adding material. So there, I will take a sip of something to drink, and I'm ready for questions. Yeah, that's actually where I ended.
Thank you very much, Scott. And I also want to mention, technically, we are running into the breakout time already, but
yeah,
Scott is supposed to be the host and
for
the next session anyway, so yeah. I will just leave the stage to you, and you have
that worked out.
Another hour.
Okay, good. Yeah, I have some very minimal notes. I should not show you how minimal they are as far as the breakout session, but I thought a place to start that is actually with the question of what is a game?
Can I ask a question about your KSP project here?
Yes, please.
Yeah. So, sorry, I'm really naive have a very naive understanding. I see a lot of nice projects, and I see the link of your website, which I didn't browse while you were talking, which I think I shouldn't anyway. So, I saw some links there with materials. Can we just download and use it?
Yeah, absolutely. I mean, really, if you wanted to email me, I'll send you the Word doc. They should, they're in Word as well. So you can really edit easily. But yes, that's what I was hoping, is that you might find something there, even if you aren't using directly, but it'll just say, oh, wow, I never thought about that. That's really fascinating. Maybe I'll explore that. And then you can see what I did with it. And you can see I put answers to what I got. So you can say, am I thinking along the same way?
Thank you.
So, yes, there's a bunch of stuff there.
And how about the I mean, I also like the gamification part. Can I assume that's not something who's not part of university who can use, or it's some kind of like everybody can register, get an
So,
avatar, begin to play, or
well, okay. So the game, that's one of the first things that you really want to ask about this, is first of all, the game you'd have to buy, and then you'd have to kind of learn, and so let's go through that a little bit. So when I did this grant, part of the grant was to just buy the game, and if you just go on, the website and say, I just want to buy it, just looks like fun, I'll buy it. It's probably gonna be $40 to buy it just straight out, like just as a individual. Now, after going further, deeper into the project and communicating with that publisher, they said, well, you know what, you can get a discount. We'll send you codes for a discount. We'll let you have the students buy it for $15. And that was great. And that would probably work. I wish I had sort of looked that up ahead of time. Thank you. The link of the site is there in the chat, right? So yeah, they were gonna. I think they would be super happy to do that $15 thing. And I'll just say that even with in my case, I don't think they really had very many people that were saying, let's do a class of this. And so it was not set up for a class to make a purchase. And so it just took it was just sort of logistically took a while, which is ended up, they just said, well, you can just have it for your project. So, so that's why I had some money left over that we could do it again in the next semester.
Okay, thank you very much.
Yeah, and then, yeah, go ahead. I see a chat there.
Yes, there's.
How do you learn about Kerbal and the grants? Does your school have an aerospace program? Right. No, we don't really have anything specific that's aerospace engineering. We did have another group, which I didn't have any connection with really, that did a NASA grant. So I think one of the ways in which you can get funding through NASA is individual regions or states collect grant money and then disperse it for mini grants. So this was a mini grant that I applied to the NASA Space Grant Consortium. So they're in Pittsburgh, I think. It's Penn State. Maybe it's not Pittsburgh. Anyway, they approved it through that consortium that was looking for mini grant opportunities, to award mini grant opportunities. So anyway, our school did a grant through them even before me to build a model rover. Some of the engineering students did that, and they invited me to come see it because they were using my navigation formula in their program for their rover. And I was like, wow, I was super thrilled to see that. And then, so we had that experience already, our school, with that mini grant. Let's see. I wonder if I think if I get rid of that, it's this NASA Space Grant Consortium. Let's see if I can find it.
I put a link in the chat. Is that?
That's it. That looks right. Yeah. Right. That's it. That's the one. That's where this started. So they were able to help us out financially with the costs of paying for the instruction and paying for some speakers and paying for the game and paying, the infrastructure of having a course run. So that's how I had the game available for students in that particular course that was designed for it. And now I've still used it in other classes. And the way that I use it in other classes is I've just, in some cases, recorded a clip of something from the game, almost like it's a video just demonstration of, an alternate reality with a different mass planet. And here's, so that's fun. And I think you don't even have to do that. If you just were doing something and you just switch the mass from Earth to the mass of Kerbin, somebody in the class might say, oh, wow, Kerbin, I know that. In fact, way before I did any of this, I was just discovering it, and I had a intermediate algebra class. And it's usually kind of a slog to get through the intermediate algebra material. And, if you don't keep the energy level up, I get bored, the students get bored, it's just another algebra. But I made a comment about Kerbal, and then I was talking with a student about, the slingshot effect you need by gravity to reach the moon, and it was a really positive experience that we would have never gotten into talking about, the math and physics of that. And it was just spurred by just a comment, so I guess there are ways that you might just be able to put a little fun and also just sort of express the universality of these principles. Like I'm using the universal gravitational constant, big G, in Kerbal, and it's the same one in real life. And just switching, the mass of a planet to something else, you find it just seemed like the lesson with the log function and how it demonstrates Kepler's third law and using different planet data, yeah, it was pretty neat. So let's see, I think there was another question that how did I first learn about it? The way I first learned about it was when we cut the cable for regular cable TV. I had an old Xbox that actually does live TV, and I thought I'd try it out. And just exploring around the Xbox, I found the game. I do not recommend it on Xbox. It's super hard, and I just about threw the controller out the window, but I found it that way. And then I was just astounded like how amazing it was.
Yeah, maybe I can say something about why doing simulators. I think that the part that attracted me the most about what Scott was doing is that he was like using computer games, and I thought this was such a new idea. I don't think it's something I would have thought about it myself. But then I knew Scott was doing it. So in the differential equations class, I have found these equations about gliders. And then I thought, well, I must do what Scott does, But then I use a different software. I use a free software that you can quickly go online and do it and do it very quickly.
Yeah.
But it's not because there is any program. It's more like, it's a nice thing, kind of like interesting thing that you can do with the students, and that is easy to do.
There's an element of fun and play that brings in some, you kind of maybe catch some people's attention and engage with that. And I think that program that's free online works better for just a typical class, and something that I'm building here might actually be more suited for an activity in a club or as a summer enrichment program. But for perhaps maybe a student project, let's say you're brave enough to say, okay, to this class, you guys, what do you want to do for a project? And this is one option. And then, it's off the hands of the teacher, perhaps, to get, all of the time commitment and learning commitment. You give them the opportunity to share something with the rest of the class that the rest of the class wouldn't have otherwise been exposed to. And the students can, there might be a few students in different levels of math that would really be happy to put in the time to develop, something that would be a great project that they could present, so they might take the cost of the game and the time it takes, even in a regular class, if there was an opportunity for a project, perhaps. So what is a game? I Googled it. What is a game? Do I still have an audience here? Where are you?
A game, yes, but a game. A game is part. I think that we play games because we learn. How do you learn about stuff? When you are a little kid, you learn a lot because you are taught, but you learn a lot when you're exploring on your own, like playing with dirt and stuff like that.
Yeah. It's really fundamental to learning, isn't it?
Eating dirt is a very nice way of learning. Because I'm kidding. No,
well,
don't do it.
Making mistakes that are not costly. You can sort of take risks, right? And so there's a
Fail safe,
yeah,
fail safe. Yeah.
right.
That's something I you said in the presentation that is very interesting as well. That that many times we're kind of very punitive in the way we conduct our classes, and we have all these grades and deadlines and stuff like that.
Yep.
And I think the way you approach the class here in all your classes is very much more kind, I would say, in a way, because it's like if you have this trial and error approach where you can try multiple times, where gradually you get up to speed.
Yeah.
It's a fail-safe environment game in a way.
Yep.
Without trolls. Gaming without trolls.
Without what?
Trolls.
Trolls.
Yeah, I would say too that, like, take the Mary Poppins approach. A game is anything that you are able to enjoy doing something, that has something constructive in some way. If it's trying to battle the bad guys and beat them, or like here, trying to make sure that your spacecraft can go without crashing.
Right.
But it's fun, and that's what makes it a game.
Yeah. And when I can sort of reflect that feeling in the class, that's a potential for some interest and discovery, and it's, when I'm having fun, I think that comes across, making the material interesting for the students. They'll just give me another few minutes to keep talking. So
yeah, you kind of know that, like, you've done something right when they want to stick around. Or they come up to you after class and they're like, oh, I was thinking of this when you started talking, and it's like related, but like expanded on that, and you're like,
yes, that's right. Yep.
It's a magic toy stick. It's so cool.
I had another note for myself about like where this conversation could go. Like, what is a game that you enjoy?
Okay, I'll need all your gold. I'm gonna make it huge.
That has seemed like it had some educational value for you.
Grand Theft Auto.
Thank you. Yeah. We were in the math club, Hector and I I was trying to talk about navigation, and I had really a plan about like seeing some sites in Microsoft Flight Simulator with some navigation, but that whole plan just sort of went out the window as the time that I had allotted was running out, and I was just, okay, let's see the Grand Canyon. And then Hector was like, I'll stay if you land. I had to land on the road, like Grand Theft Auto, with my airplane. That was the best part. That was fun.
I can add something.
Yes.
So there's not a lot of math in it, but the game Fortnite's very popular, and there's many similar games that are of that same realm. And in those games, the world environment you're playing in collapses along circles, but they're not concentric circles. So you essentially have a straight line homotopy that's connecting one circle to the next. There's a probabilistic component in terms of where the centers of each circle appear. And so there's a lot. I've talked about that in sessions to high school students and college students as well. I'm a topologist, so that sort of interests me. So that's one area, and it's just, I think that's pretty neat. It's not as in depth as Kerbal is.
Well, it sounds like you get in depth right away, and all you needed was that sort of like just sometimes connection, just to spur the imagination. Right? That's neat.
And another thing that always interested me when I was younger, there's a game, it was called Forsaken, like in the mid 90s. And it was during the early days of 3D video games on Nintendo 64, and the world in which you play in is not Euclidean, so to speak. I mean, it's Euclidean, but I never, even for myself as a topologist, took enough time to think about what manifold you're playing in, because you essentially enter one room and you come out in another room that you were in earlier. So there's loops within the space, and I'm still baffled how designers at that time,
it's beautiful,
knew to create that, or if they had any topologists or any mathematicians on the in the design in the company for that game. I don't know, but I haven't seen anything quite to that level since then. And this was
they were talking when we had in the math class at our college. Scott invited the developers of KSP, and at some point they were talking about stuff like making a tunnel, and you enter through one side of the tunnel and you come out larger, like some kind of a scaling transformation. And then you go the other way and you come smaller. Do you remember that, Scott, at some point? Or am I misjudging? Or did I see it somewhere else?
Well, I don't know. I don't remember. I remember a lot of really fascinating math topics that they shared in both of those sessions. Say that again, because
for instance, I saw somewhere, I have seen some games. What they have is like a tunnel.
Yeah.
And you enter through the tunnel, and you come out of the tunnel being smaller. And if you go back, you come out larger. Or there are like rooms where you can enter, but if you exit through the door, you go into another room and stuff like that. So it's like exactly what Jared was saying, I think. But yeah. I thought it was a modern thing. Maybe I saw it in YouTube.
I don't remember that in our discussion, but one of the things I was thinking about from what Jared was saying in that discussion with those developers, I guess that, is there some training going on there in all of those hours, that the students, future, topologists maybe are developing, some imagination, right? That's useful later, right?
Yeah, I would hope
so.
for that.
Yeah, I hope so. There have been studies, right, that suggest that the game playing is sometimes productive.
My son plays. Hey, what's the name of the game you play? What's the name of the game you play? The computer game you play? Minecraft. My son plays Minecraft. Yeah. And it's amazing.
Right.
It's amazing.
Yes.
I think it's super good for them.
I think that's a top of the list one. I don't really know much about it. And
at our university, the students, I don't know where they're at on this, but the students are in the process of wanting to build an entire model of our entire campus on Minecraft. I think he was partially inspired because when I had class, I think with this one student that's leading the project, I had built a model of our university in Fortnite with the building in that, and which is sort of based on this Minecraft idea. So they really wanted to pursue, this Minecraft project, but I'm not sure where they're at on it now.
One of my cousins is working on his applications for college for an engineering program, and it all started with Minecraft. And the Minecraft, and then just basically, I really need to get some more discussion with him on that, because he wanted to program, and that led him to engineering, and I think it really started with Minecraft for him. And he's looking at,
he's building, my son is building a lot of buildings, and kind of like constructions, like they have like stuff that they can add to like windows, specific materials. You wouldn't believe, it's amazing. It's amazing. I think it's very good for him to play it. Not too much though.
Right. Got to balance it.
Yeah, that's the struggle right there.
Yeah.
And I guess that's the thing with your students too, right? Like you want it to be fun, but you don't want them to get too focused on the fun part that they don't get the connections.
Yep. Right.
Indeed. And also the learning these computer games, unless you actually set some specific activities beforehand, and you prepare very closely. Learning the computer games already, I think, is a considerable chunk of time.
It is.
That could go into learning, I don't know, some other aspects of, of mathematics that,
right.
Yeah, great point, Heather. Yes, very important.
Hector and I've talked to him about this, and I just wonder if, we can sort of carve out a place in the summer before school starts that we can catch a few high school students and inspire them to explore, where it doesn't interrupt the traditional path, but in that space where a grant even could buy the game, we might be able to really, have some fun and have some learning really happen there.
Yeah, summer programs are a great opportunity to do that. Have any of you guys run a summer program before?
I haven't.
No, I mean, it's a lot of, I think it's a lot of work. I haven't either, but there was another faculty member who did run several summer programs when a few years
in person.
ago.
Yeah.
But it is a lot. It's a lot of work. But speaking of that, I have a question. Like, this is all really cool, but it's really intimidating. Like, what's the learning curve?
Oh yeah.
To prepare what you've prepared must have taken a lot of time.
I think it was in around 2018 where I first discovered the game, right? And then to write all that workbook, it's spread out over a long time, plus some time in COVID where there wasn't much else, to do. But I didn't even know there was a rocket equation when I started this. There's something called the rocket equation. How did I not know that?
Yeah, so every time they say it's not rocket science, you can be like, well, actually it is.
I know, and that's fun. That's totally one of the fun things. And yeah, I think people enjoy that. It is rocket science. It's totally one of the jokes that starts, in that Kerbal class, we're really doing rocket science, and they love it. And we just start with real basic stuff. And pretty soon it gets like, yeah, that's a really good question. And you're talking about, really neat topics that the vis-viva equation and the delta V for the transfer orbit, and just a rocket equation that includes quadratic drag, quadratic with velocity, so it's a nonlinear differential equation.
Yeah, but if you can provide sort of the scaffolding so the students don't have to tackle the equations on their own.
Yeah, so that's right.
Sudden...
Brings back to, the sort of like, it's still nice to have somebody who has some experience and prior training and can look at sort of an organized way, to get through some achievement points, like, we can really talk about, that list that I had there on my schedule. It looks pretty impressive, and I feel really pretty good about it. Let me put that back up there. Where'd it go? Orbital period and kinetic and potential energy and linear and angular speed, and it was a nice thing about having 2 hours a week to talk through those things. So it was really a neat experience. So one step at a time. Yes.
I think you talked about it some, but I was still a little unclear. Like, for the student work, I mean, were they doing sort of capturing data from the game and reporting that in their homework?
That's right. Oh, that's right. Absolutely. That's right. You can do that a couple of ways. The easiest thing is as you play, you can hit the escape key and it freezes and you can write something down that you see on the screen. That's like level 1. Just do that. Hit, pause the game, write down the value. You can actually, now it takes an added mod. It's free, but you have to download the mod and install it in the game, and then it will download data. And then you can, it's like, for example, it looks like, I can show you right here. Let's see, where is it? I have a folder for Kerbal Space Program, and I have a game data folder, and I have a mod called MechJeb, which has export data, and that is right here, data that's downloaded from the game through the mod that shows altitude, downrange, speed relative to the surface, speed, the orbital speed, mass, acceleration. That's the atmospheric pressure right there. Angle of attack, I understand that. Angle of slip and angle of, I don't even know what that is, actually. Pitch, I know that. I'm not sure what these really mean, gravity loss, drag losses. I haven't quite been able to figure that out, so I'm still learning that. But that's time stamps. It seems like every 12/100ths of a second for some reason. Yep. So, yep, you can download from the game in a format that then, I can analyze. And Hector and I both, we're kind of working on right now, like taking, that's the, down there at the bottom, those are the Excel, graphs of altitude, pitch, and speed when I turn off the engine and just let it glide. You can actually see that mod running in the game in that image. And then I had a model with some, what I'm doing in this slide really was just adjusting the drag or some parameters there to try to get a model that actually is similar to what I see in the data. And that's as far as I've gotten with that one. That's pretty much what what I think I did actually here was I did it both ways. Like basically just hit the escape key, the game pauses, write down the speed, write down the time and the speed. And then I also downloaded the data. And then I had Euler's method in Excel, and I figured out what the speeds should be based on this. Basically, I'm solving for dVdt, right? And I have a constant thrust, I have a changing weight because the mass drops as it burns fuel, and I have an increasing speed, so I can't solve analytically for the acceleration, but I can find the solution with Euler's method. And so that's a lesson now in my differential equations class, and I have a video that has a launch, and basically it's just the question really just does it match the data that you see in the video, and that's what I do in the DE class. Just create the model. Here's the given information, solve it with Euler's method, and then if they wanted to, they could check it with the video.
Thank you.
Mm-hmm.
Were you thinking of proposing doing something with high school students sometime in the summer?
Yeah.
I mean, there's one piece of time that this might be too short and not useful, but there's a piece of time at the end of the semester. So this is kind of basically May, after the AP, when the very good students who've just taken the AP are at loose ends.
Yes.
And their teachers would love to have them.
That's exactly right. As a matter of fact, a high school teacher in Philadelphia at a school like a charter school in Philadelphia emailed me out of the blue, said, I found your material. I want to do this with my class because they're sitting around. They don't know what to do. I mean, they don't want to do anything. And they've got a month left. They don't want to do anything because they're already pretty much know where they're going and for college. And I've got to do something with these kids. And so, yeah, that's what he did. And I don't know whether he was able to get the game from, I think, I put him in touch with the publisher, and I think that he probably did a test, pilot with that game last year. Yep, that's right.
Yeah, that's totally brilliant, because I remember being in high school and feeling like this is the most wasted time of my life. I'm like, I've got how much more time in high school? Very little. And what are you doing, showing movies?
Yes, right. So maybe you can get him to play Kerbal and then ask him a few questions. How's it going? Can you answer this question? Spur him to think about it analytically, or just sort of critically about what's an interesting problem that you can solve. That's the thing with that game, is it's like really so open-ended. You don't have a score. You don't have any specific thing that you have to do. You just create your own missions, own objectives, if you want. So maybe you can get some interesting, some students there at that level, right? That's a good idea.
If you offered an online version of this where
Right.
you were kind of guiding it, then the 1 or 2 kids from each school who are really gung-ho and wanted to do something extra, you could guide. And I think it might be super useful. You could offer them, I don't know, some certificate at the end of it or something. Basically, they're not going to care about that much because the AP matters more. Right. But I think it's a wonderful project. And for the kids who wanted to do it, even in May, a wonderful opportunity.
Yeah. Well, if I could get Scott Manley to come back, they would sign up, I think, just to be able to talk to Scott Manley. So maybe he would go for it. How are we doing on time? What's our schedule say?
Is this room 2?
I think it is.
Okay, so I think I might be doing let's see, which room am I in? I think we have about 15 minutes till the next session starts. Yeah. And so I'm going to be back.
Are you? Yeah, and I definitely want to see Tim Penning's.
This is the second one, right?
He's R1A.
Oh, so then you need to make sure that you leave.
And you're in R2A.
So I'm still here.
Yeah. Okay. Right. Well,
but we've got a little bit more time if anybody else has questions. So I still have these questions about, like, so if I were to say I was to buy this game, and just like open it up, like, would it be self-explanatory how to use it?
It does have a guide. It's it does actually have a guide that would lead you through it.
And is it actually like a game, like that there's actual, like, a goal that you need to accomplish, or is it just sort of like a sandbox?
It is, a matter of fact, it has 3 modes. It has a sandbox mode. And that was one of the things that I had to learn first, is that if you go to sandbox mode, there are actually already made rockets and already made airplanes. And that was a really important thing to discover. Put it on sandbox mode. And the problem with sandbox mode is that sort of like that's the shortcut now to just get in and get things going. And then, if you go to the other mode, like there's a science mode. And in the science mode, what happens is if you achieve certain things, contracts, then you get more equipment and parts and things that you build a tree. Basically, you unlock more, things that you can work with. And so that might be a little bit more like help you sort of develop as a player. So I never did that. I went right to the sandbox mode. And then my goal was just about the lesson and the math. And so I didn't develop fully as a player as I might have otherwise. So there's a science mode, and there's a career mode, which is more about developing your space center, as like the Kerbal, it's sort of like the equivalent of NASA. You're developing it, you're more in terms of like finances rather than science objectives. They're finance objectives or something, I think, in that mode. So yeah, so you will see, if you started it, there will be like a hello, and it's like Werner von Kerbin or something. He's the Werner von Braun of the Kerbal system, and he will guide you through and say, this is over here and that's over there, and you click this and that, and yeah, it's a little.
So then the other question that I have is, because I was kind of, as you were talking, looking at some of the resources that you put up there, and
yeah,
it looks like you use multiple other platforms for
that's right. So
doing other things.
Yeah, let's see if I can go back.
So from the student's perspective, how many different platforms do they need to be able to navigate through, and how much of it is stuff you've kind of done for them and they just look at it?
Yeah, well, I guess it was just really the Kerbal game that I really wanted to see that they were in that. And then the stuff that I put on Geogebra was just really my sort of teaching, tool. And so let me see, where's my
So
actual.
most of your stuff is Geogebra, and is that's basically math, I would imagine, based on the name.
Yes, and it's really, really neat. Yeah, so right, I just kept adding stuff to this, so it's not as organized as I would like.
Yeah, because that's what I was
make.
looking through, and I saw all these different.
Yep. So these are little, just they would be something I think of as like the diagrams in the textbook, but these are interactive. And
so all of these that you have here are interactive?
Yeah.
And you built them all?
Uh-huh. Yeah. Yeah. And then, I was just using these to talk through the videos that I made and to talk through in that class that I taught. And then there's Mike Aben, who's another YouTube creator that actually came to the class once and did a presentation about basically the delta V you need to transfer an elliptical orbit to another orbit to reach the moon. He did that lesson, and he has a whole bunch of let's do the math videos that are short and use Kerbal to teach. And then also at the very bottom, he has videos that are really like super beginner, just like how to play and how to get started. So I made that connection with him, and he came to the class and did a presentation, and then I've got his videos on here also. So that gives you an idea what it looks like and what it's sort of like, how it plays. These are all like, that's something just generated a long time ago for actually last year. That was the actual Mathematica code that models the launch of the rocket, and here's the Excel version of it. And then, all of these different things, Excel for little, experimenting with the concepts. And then I was basically making these also for the videos that I made.
So how much time does it take to make one of these?
Oh,
like, are you just like so good at it now? You're like expert programmer, like in the movies, like boom, 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 and it's gone? Or is it still like some head
like
scratching?
Yeah.
Because I feel like every time I want to tackle something like that, I'm like, okay, take a deep breath here. Let's figure out if it's really worth the amount of time it's going to take me.
I feel pretty good because I can just be in class and I just turn on Desmos and I can graph the function. I can find the area under the curve. I can put little sliders for the A and B, all of that while I'm talking to them.
So you can do that kind of in real time.
I can do that in real time now. Yes. And I can get it to shade, all that stuff. So that's in Desmos. And then GeoGebra, I need to set it up usually before class. I've used GeoGebra some neat things in the linear algebra class. So I'll set that up before and I'm better at it. And it's it over quite since really 2019 is where I was like, oh wow. One of the other faculty in the school was like, why don't you make a workbook on this? I was like, oh yeah, that's an idea. So then I started that probably in 2019. And and then I was about to give up, and then there was a presentation for Pearson in 2020 that they said, hey, that looks interesting. So then I prepared the presentation, and then that was really fun. And that eventually it was 2020 summer, and then I was like, okay, I'll try this NASA grant, and that worked, and that was really fun. So it just kept on like that.
Mm-hmm.
You know, one thing I was going to ask you about MATLAB, the reason I'm kind of interested, I have this book that hold on a second. So orbital mechanics for engineering students, and it's got MATLAB examples, and I want to use those MATLAB examples.
Yeah.
So that's why I was interested. I guess I don't know what
So
question was, but
do you have access to MATLAB?
No.
Yeah, that's the problem with stuff like that, is that you know, you have to have MATLAB to run it.
Mm-hmm.
Now sometimes, so one thing that could happen is if these examples are like ready to go,
yeah,
then you can find someone who does have access to MATLAB,
right,
and they can potentially make executables out of them.
Right.
And then all you need to do is download a MATLAB runtime engine, which is free.
Right.
So if you wanted to work in collaboration with somebody,
Right.
and then the nice thing about that is that then you can hand those executable files to your students. They can do the same thing.
Yeah.
Like on their machine, they can just download this runtime engine, install it on their machine, and then they can run these executables as well. So that might be a good first start, is just, you know, find someone that you know that has access to MATLAB, and
Right.
And then that way you can at least look through them and see if there's anything that's any good.
If I want to keep going. Yeah, because I think I'm right at a point where I can either go further into Wolfram Programming Lab and just that's where I'm going to work. Because I originally, as I started all this stuff, I really thought it was going to be MATLAB that I was going to develop. I thought, in fact, that was one of the things that I thought was going to be in the grant, was like buying the MATLAB access. Didn't have to really do that.
Yeah.
Because I ended up really targeting more like those, you know, just sort of intermediate algebra. That's the way the grant sort of turned out. It was like, let's look at students that are intermediate algebra that might go business or non-STEM, or some that go STEM.
Yeah,
and just,
I mean, MATLAB is definitely best for, you know, matrix algebra. That's kind of what it's originally designed for. That's what the name MATLAB comes from. So like, yes, solving systems of differential equations, or solving systems of equations, linear equations, and then, you know, coming up with methods for, you know, doing like curve fitting and stuff are all like ideal for MATLAB. The visualization is a little bit challenging, so you probably are better off with some of the platforms that you're using already. But I think, you know, if you have access to Mathematica, right? You said
yeah, that's the thing. It's free for for Mathematica.
So like,
though.
I mean, that's the thing is, you know, I'm kind of pragmatic, and I'm like, if you've got a resource and it's available for you and your students, then and you can figure out how to make it work, then that's probably the best option for you.
I know, and I have to sort of figure out like how important is it to get them that exposure to MATLAB in the community college, because of its significance later in their program. You know,
I mean, you know, you can give them a little bit of exposure just simply by developing something where you can show them, hey, when you did this in Mathematica, this is the way you would do it in MATLAB, just so you know, like.
Yeah, and just find somebody who's got also interest in this project that maybe can put together an executable and say, this is generated by this.
Yeah, I mean,
here's the code, we did it, we generated, you can run it yourself. And,
yeah, if you run something and you're like, this is exactly what I need for my students, then they can probably help you do that.
Yep.
Yeah.
Thank you for checking out this project. It's been really fun. And
yeah, it sounds
thank
like
you
it.
all for letting me share that, because yeah, it's been fun.